My name's Steve Souders. I work at Google, and I work on web performance. I try to make websites faster. And I've been doing this for about 4 or 5 years. I've been at Google about a year and a half. Before that, I was at Yahoo for 8 years. And all the talks, I do about 15 or 20 conferences a year. And for the last year, all the talks have been titled Even Faster Websites. But it doesn't mean all the talks are identical. And in fact, today is the first time. So I have, 20 or 30 different performance tips, and I talk about a different set depending on the audience or what I haven't talked about recently. And I've been saving back one performance tip for Google I/O because it was researched by my office mate, Tony Gentlecore at Google. So I really wanted to set that aside for Google I/O and pay tribute to Google by releasing it, revealing it first here. So the talk today is 3 parts. I preamble a little bit about performance and where I focus on performance, where I think you really need to focus to make a big dent in page load time. And then I dive into these performance best practices. Today I'll be covering 3 of them. And then I wind up with a little punch to get us motivated to go home and make our websites faster. And here's the URL. I'll have it on the last slide as well. Or you can just go to stevesouders.com, and you'll see a link next to Google I/O for these slides, so you don't have to take mad notes or anything. So I think one of the biggest things that I've contributed to the world of web performance is getting people to focus more on the front end than the back end. When I started my career at Yahoo and before Yahoo, I was mostly building big back-end architectures, databases, data feed systems, large websites. I ran my Yahoo team for 3 years. And about 4 or 5 years ago, the folks at Yahoo asked me to start a group to look at making websites faster. And that, I'm embarrassed to say, was one of the, well, it wasn't the first time. It was maybe the 3rd or 4th time that I fired up a packet sniffer. So here's a packet sniffer called IBM Page Detailer, and you can get a limited version for free. And the horizontal axis is time, and the vertical axis are HTTP requests. And so we can see we start with, of course, the first HTTP request is for the HTML document, and we have these little icons over here that give us a clue of what's being downloaded, and a style sheet, a script, and a bunch of images. And what I noticed when I first fired this up on my Yahoo about 4 or 5 years ago was that a disproportionately small amount of time was spent on what I call the back-end part of this page load. So the biggest, most back-end intensive part of fetching a page is generating that HTML document and the HTML and the other components that are inside of that. And so that's where, in all of my career, when I was trying to make websites faster, that was the portion of the page load time that I had been focusing all my attention on. And really, like in this case with iGoogle with an empty cache, 91% of the time is what I call the front-end time. So this is where the browser is parsing the HTML, the CSS, the JavaScript, applying styles, executing JavaScript, and also doing more HTTP requests. So there is network time, maybe a little bit of back-end time, but not that much because these are typically static files that are being read off disk or out of memory cache. So we see 91% of the time in this situation, iGoogle with an empty cache, is spent on this front-end part. So maybe 4 or 5 years ago, a lot of attention in making websites faster was in improving, your Apache handlers, your C++ code, your database indices, and really that is just improving this 9% chunk. So when I noticed this, I said, well, maybe this, longer pole in the tent is the place we should be focusing. So I looked at this a little bit more. I said, well, what if the cache was primed? Because really about 80% of page views for any website are done with users that have a primed cache. And we still see that only 17% is getting this HTML document, which involves the most intensive part of the back-end work, and 83% is the front-end part. So this big white gap is where there's no network requests going on because all of these resources have been cached to disk, but the browser still has to read those files off disk, and if they're CSS or JavaScript, parse them, execute them, apply them, etc. And this isn't just true with iGoogle or my Yahoo, like I discovered 5 years ago. Here's the Alexa top 10, and we see for a majority of these, less than 10 or 20% of the end user wait time is spent getting the HTML document. And that actually includes the request going up, the back end stitching it all together, and all of the packets, the response, coming back. So that is less than 10 or 20% of the overall time that the user is waiting. So really, if you want to make websites faster, you've got to focus on this front-end part. I think that's one of the biggest things that I've tried to promote, evangelize among the web development community. That's having some positive effect. So I call that the performance golden rule. If you want to make websites faster, you've got to focus on this front-end part, because that's where 80 to 90% of the page load time is being consumed. And there's 3 kind of lessons learned for why that you should keep that in mind. Just a priori probability, there's a greater chance of making an impact. If you could cut that back-end time in half, you'd only do a 5 or 10% dent in the load time. Whereas if you can cut this front-end time in half, that's 40 to 50%. So it's going to be much more noticeable by users. The changes are simpler. If you want to cut the back-end time down, you've got to replicate your application logic across multiple data centers and database replication. You've got to analyze your database queries and your indices and improve those. Maybe change your code design, the way your compiler options, things like that. These are multi-month, multi-year sorts of projects, whereas the things that I evangelize changing are things like turn on compression in your web server, move a script from up here to down here in the page. These are changes that take person hours, person days at the most. So they're simpler changes, and they're proven to work. So every week I get 2 or 3 emails at conferences like this. People come up, and the typical feedback is, I applied, or at my job, we applied 3 or 4 of your performance best practices and cut 25% off. So if you find the ones, for example, reported by YSlow, that are the most important ones to fix, and you fix those 3 or 4, it's pretty easy to get a 25% speed up. And I've seen sites get as much as a 50 or 60% speed up. So those are the reasons why you should focus on the front end. So as I started this work at Yahoo, investigating this area, so now I knew, okay, well, we want to focus on making the front end time faster. So where's that time being consumed, and what can we do to cut that time down? I came up with this list of rules. So this was from doing research, going around and talking to other teams. I found that the same mistakes were being made over and over and over again. And I started, as we fixed these and we saw how much of an improvement it made, I started keeping a list of the ones that most consistently improved websites, and I ordered them in the order of having the highest impact. So, for example, if you can reduce the number of HTTP requests, that's the most important thing you can do to speed up your website in most cases. So I had these rules, and I would go around and do consulting with different teams within Yahoo, and there just wasn't enough time to reach everybody. So I wanted to capture this logic in a way that teams could analyze websites themselves and find the best advice of what to work on. So I built this tool called YSlow, and it started off as a bookmarklet and a grease monkey script, and finally became an extension to Firebug with Joe Hewitt's help. And this is YSlow 1. I haven't updated the screen dump. I should do that. And basically, you can run it on any website, and it tells you, it gives you a grade for each of these rules. Each of the rules is a link, so you can click on it and see a one-page description of what that rule is trying to point out. And then it analyzes the web page and tells you exactly what needs to be fixed on the web page to raise the score for that rule. And so this is really good. Now people can run this and get specific list of improvements to make. It's almost like a to-do list for your project. And going a little bit out of order here, I started going around and evangelizing YSlow and these best practices, going to companies and giving talks, Amazon, Microsoft, Zillow, companies like that. And what I found was there was this community of web developers that really were passionate about performance and making the user experience faster. And so I talked to Tim O'Reilly about the need to create a community for these engineers to come together. And that was the start of the Velocity Conference. Jesse Robbins and I co-chair that. I work on the performance part. He works on the operations part. And so we had our first year last year, was extremely successful. Twice as many people showed up as expected. And we're doing that again next month. And there's a 15% discount code if you want to go. And I've got some flyers up here on stage if you want to take something with you when you leave. So that's coming up. So I evangelized there. Also last fall, I taught a course at Stanford called High Performance Websites. So I've got 30 hours of slides that we could go over in more detail at some point. And actually, they just put last week they put the video, all 30 hours of video of the lectures are now available up on the SCPD website. And September 2007, I got my first book published, High Performance Websites. It did really well. It climbed to the #1 spot on Amazon's computer and internet category. And it's still doing pretty well. And it's a good book. Here, I've got it here. I carry it with me because I'm a little absent-minded, and people ask me questions about it, and I have to look it up. And one of the things I felt bad about when I got the first bound copy was how thin it was. I felt a little wimpy. And I've gotten nothing but positive feedback on how easy it is to read and get through it. Some people read it in one sitting. And so I haven't been sitting idle since then. I've been working on a follow-up book called Even Faster Websites. And that should be coming out in just a few weeks, June 15th. And these are the chapters that I wrote for it. And as much as I like thin books, and I hope you do too, this would be a very thin book. And I had other chapters I wanted to write, but I found I was just reiterating things that other experts in the field had already been talking about. So I just asked these people if they would contribute chapters to the book. And luckily they said yes. So we have Doug Crockford talking about, at a high level, the importance of performance with regard to Ajax and JavaScript and JSON. Ben and Dion talking about creating responsive user interfaces with Ajax. Nicholas Zakis at Yahoo, a big JavaScript guru, author, talking about some more fine-grained performance optimizations to be made with JavaScript. Dylan Sheeman runs SitePen, the Dojo project, and also Comment Daily blog. He's going to talk about Comment. I'm going to talk, my office mate, Tony Gentlecore, wrote the chapter on going beyond gzip, which today will be the first time it's been discussed publicly. And Nicole and Stoyan, of course, the industry experts on image optimization, wrote the image optimization chapter. So today I'm going to talk about flushing the document early, simplifying CSS selectors, and going beyond gzipping. Okay, so that was the first part of the 3 parts of the talk, the preamble. So now we'll get into the meat. And flushing the document early, or the potty humor rule, as I like to call it. So here's a typical waterfall chart that you might see for some HTML page. The first request is an HTML document, and it has some images and a script. And this is the way you would normally expect to see it load, right? The HTML document comes back, the browser parses that, figures out what resources it has to download, downloads those resources, and renders the page. And the bad thing is that when the user clicks on the link right here, there's nothing that happens in the browser until right here, right? This stuff is coming back, and all that time the user is waiting and the browser is idle, not really doing anything. So is there a way that we can take advantage of that idle time? And it turns out there is. In PHP, there's this function called flush. In this case, this example is my website that's written in PHP. So at this point in the page, after I had assembled the head of the HTML document and a couple images up at the top and a script that was in the head, I called PHP's flush function. And that sends, normally, as you're echoing output from PHP, it gets queued up in standard out. And then finally, at some point, typically, depending on the size of your document, but typically when you're done with your PHP template or script, then it gets flushed to the user. But by calling flush explicitly, I can get all of those characters that have been buffered in standard out sent over the wire right at that point. And all browsers will take that partial response and start parsing it and acting on it. So we can actually get the browser to start downloading and rendering resources even before the entire HTML document has been finished being stitched together by the backend server. So this is really powerful, but there are a lot of gotchas. If you read the man page, the document page for Flush on PHP's website, you'll see a lot of people complaining about not being able to get it to work. And So here are some of the typical problems. If you have output buffering on, that's actually another layer of buffers on top of standard out. And so if you just call flush, there isn't anything in standard out to flush because it's been buffered in this output buffer. So you have to call the OB functions, like OB flush, to actually flush that to standard out and then call flush again. I go into more detail on this in the book and a blog post I wrote about it. Typically, you have to have transfer encoding, chunked encoding enabled, and most web servers, IIS and Apache, will take care of this for you. But if you ever see that it's not working, if you're trying to get this to work and it doesn't seem to be working, look for that transfer encoding chunked header in the response. If you don't see it, you've got to get that working to make it function properly. If you're gzipping your response, which hopefully you are, and you're using Apache earlier than 228, there's an 8K gzip buffer. The deflate buffer size is 8K by default. So you either need to lower that or have 8K of compressed content when you call flush. Otherwise, it actually won't get flushed. If you're running antivirus software, security software on your client, or you're going through an intermediate proxy, many of them will not honor the flushing, the chunked responses. It'll queue them all up and hand them all off to the browser in one chunk. So you have to check for that and make sure that those intermediaries aren't stopping flushing from working. And then finally, you'll get through all of these, and it will work on IE or Firefox, but not on Safari or Chrome. And that is, if your flush chunk is too small, in the case of Safari, if it's under 1K, or Chrome, if it's under 2K, and in IE, it's 255 bytes, then the browser actually won't start acting on it. So you might need to get over those thresholds to actually see flushing work. And it's flush in PHP, but most other back-end templating language have a function that has flush somewhere in the name. In Perl, there's auto flush, Python flush, Ruby flush. So you can probably find something like flush in whatever language you're using. One other gotcha that I've tripped across before is where here I'm using IE7, which will open 2 connections per server name. And this script down here at the bottom is on a different domain, but these 2 images are on the same domain as the HTML document. And so when I called flush, I expected all 3 of the resources, the 2 images in the script, to all start downloading early, but one of them didn't. And I couldn't figure out why, because there's only 2 images, and it should open 2 connections. And I forgot the first connection to that server was still being used by the HTML document. So until the HTML document finished, this image was blocked. So if you are trying to get multiple resources downloaded as part of your flushing, make sure that you're not getting blocking with the main HTML document request. So if I move that image to be on a different domain name, then I get all 3 of them downloading early. So I looked across the Alexa top 10 and found, I was glad to see that Google Search was the only one that was doing flushing that was very obvious in the download. And so here we see I'm downloading Google Search results page, and we get this image request that actually starts downloading even before the finished search results have arrived to the browser. And what this is the nav logo image, which is a sprite. And this is really great that this is being downloaded early because that word Google is displayed at the top. So by flushing it right after that point in the page, it kicks off that image download earlier than it would have otherwise, and it allows the browser to render that top part of the page, giving the user progressive rendering, that feeling that the page is responding to them faster than it would have otherwise. This is a great success story of how flushing works. We get resources downloading earlier and the page rendering earlier. So it really promotes a faster user experience. Okay, this one's a little bit longer, simplifying CSS selectors. So I didn't talk about CSS hardly at all in the first book. And up until about 6-8 months ago, I hadn't spent too much time researching CSS. But about 8 months ago, there started to be more and more discussion on the popular blogs about CSS and performance. And so for this book, I wanted to dedicate a chapter to that And I think the main performance problem that gets discussed is the performance of CSS selectors. So let me dig into that a little bit. So this is a CSS rule, and we have the selector part, TOC greater than LI. The other part, the actual styles, is the declaration block. Each part of the selector is a simple selector, and here we have the greater than combinator. And I'll talk about these combinators a little bit more. So there's different types of those CSS selectors, so I'm just going to focus on that first part of the rule, the matching part, the selector part. And these are in order from simplest to more complex. So there's ID selectors. So this will match the element with ID equals to TOC. There should only be one of those in the page. So this is going to be very easy for the browser to match. Should be very fast. Class selectors, any element that has class equals chapter, this rule will match. Any element that's an anchor, this CSS rule will match. Now we get into some more complex ones. So here we're using the plus combinator. These are adjacent sibling selectors, so two elements that are previous next to each other. If we have an H1 and the next sibling element is a one with ID TOC, then this styling will match. Child selectors, any list item that is a child whose parent is TOC, this rule will match. This is kind of like a child selector, but it matches any ancestor. So any anchor at any depth under TOC will be matched by this selector. And there's more. Universal selectors, very painful. The star will match all elements. Attribute selectors, the browser actually has to check for elements that have this attribute, and if a value is specified, does the attribute match the value in the selector? And then these aren't really selectors, but I wanted to mention them, and they do carry a pretty heavy cost frequently. Pseudo classes and pseudo elements. So these are for customizing rules for behavior that's not captured in the DOM, like hover. So probably the most popular, if you do a search for efficient CSS selectors, you'll get this result as the #1 result. And the first sentence reveals, I think, what previously had been a little-known fact, that the way all browsers match CSS selectors is not left to right, as many of us English readers would have expected. It actually matches right to left. So now, when we look at these rules that at first seemed like they wouldn't be much of a performance problem, we can see that this could really challenge the browser's performance in the loading of the page. So here, instead of like I have a TOC element that has 6 LIs in it, I'm thinking, okay, well, the browser finds the TOC and then finds the 6 elements, that list item elements, that's easy. Instead, it's the other way. The browser has to look at every LI in the page and look at its parent to see if it's ID equals TOC. So depending on how many lists you have, that could be a pretty expensive match. This one's even worse. Again, TOC only had 6 anchors, so I think, okay, what's the big deal? Find TOC, find the 6 children that are anchors. Instead, it's the other way around. The browser has to find all the anchors in the page and not just look at the parent, but climb all the way up the ancestor tree until it either finds ID equals TOC or it reaches the document root. So this is could be a real performance problem for browsers. So this document gives some advice. I'll go over these pretty quickly for improving the efficiency of this matching, CSS matching challenge. Avoid universal selectors. That is going to have a lot of matching. There's no point in qualifying ID selectors because it should only match one element in the page. Similarly, you could customize classes associated with tags into a new class. There's a little trade-off here. This is going to add page weight and reduce the flexibility of your CSS a little bit. So you have to take that in consideration as well. A couple of these do that. So here, again, create a custom class. A lot of times when we use descendant selectors, we really know that we mean child, and child is going to be a little more efficient. So look at your descendant selectors and see if they could really be child selectors. But then again, do we really need child selectors? Could you figure out a way to create a custom class in that case? And finally, you might not need all the rules that you have if you relied on inheritance of styles. So all of this is mentioned in this document, which really I hadn't, I've been doing performance stuff for 4 or 5 years. I hadn't seen this until about 6 or 8 months ago. And I wondered why. And if you look at the title, This document was actually written by David Hyatt for people working on the Mozilla Chrome. And I think what's happened is, he wrote this in 2000, 9 years ago. I think what's happened is we're finally getting to the point where our Web 2.0 apps are getting so big and having so much CSS and having such a longer session life that we're getting into the same problems that were happening 9 years ago with Mozilla, where we're getting so many rules and so many elements in the page that have to be matched that we're starting to know the performance problems of this CSS selector matching. So there were some tests published by John Sykes about 6 months ago. He's since taken them down, I think. But he created these tests that had 20,000 anchor elements and did different levels of CSS. No styling had no CSS at all. The tag test just had one rule. The class test had 20,000 rules, so each anchor had its own class rule. And then he took those class rules and put them into a descendant selector and also into a child selector. And what we see is, for some browsers, like Safari is the yellow one, it got 5 times slower, right? So this is pretty scary. And IE also did pretty poorly. But what happens when you do things at a massive scale like that, you have to take into consideration if the results that you're looking at are linear to what you might expect in the real world. And here we see that in IE, there's a cliff at 18,000 rules. And since these tests were on the right-hand side of that cliff, or from your perspective, the right-hand side of that cliff, it really isn't a realistic test. So I looked at the popular websites, and for these sites are about 1,000 rules and 1,000 elements. So I redid the test at that level, and we see that there's only about a 30 millisecond penalty in having these more expensive rules. So that made me think, well, then our CSS selector is really not a problem. Do we not have to worry about this? And it really is something that we do have to think about, but we need to focus on what are the types of selectors that we should be working on. So the reason that the div p a class 0007 rule isn't that painful, even though it looks painful, right? It's 5 levels of descendant checking. This part is only going to match one element in the page. Whereas this one, which actually looks simpler, now that we know they're parsed right to left, we're going to start with this part called the key selector, and it's going to match a lot of elements in the page, so the browser's going to have a lot of work to do. Whereas this one, that might actually look more expensive, is much faster because there's only one element that's going to match. So the browser really quickly can discount some of the work that it's going to have to do with this one up here. So I created so here are some other examples. If you have a lot of divs, basically you want to look at your rules, focus your performance optimization on rules where the rightmost simple selector, div, a, here it's an attribute, here it's a pseudo class. You want to focus on the rules where that rightmost key selector is going to have the most ambiguity. It's going to require the most work from the browser to match it to elements in the page. So all of those tests focused on how this matching would affect load time. What about reflow time? So that's a time when you change something in the page and the browser has to repaint the page, re-render the elements. So this we see happening now again in the Web 2.0 AJAX-y DHTML world is happening more and more because we're doing these DHTML actions in JavaScript. And these will trigger a reflow in most browsers. So I wanted to look at which of these DHTML actions would trigger a reflow, and how painful was that reflow in different browsers. And so here's a list of about a dozen DHTML actions that I came up with. I tested them across these browsers. I haven't done this in an apples-to-apples way, so I didn't want to show absolute time values here. So I just used this 1x placeholder. So like we might look at IE6 and 7, there's a certain amount of time it takes if you change the class name of, say, a high ancestor element like document body. If you change the class name, it's going to take 1x amount of time for the reflow to happen. But if you change the padding, it's 4 times as long. And in these tests, the value of 1x is somewhere between 1 and 6 seconds. So that changing the padding in IE6 and 7 is going to be somewhere between 4 and 24 seconds. And this was on this laptop. So these things can be pretty painful. And this wasn't at 20,000 elements or 20,000 rules. This is at the real-world levels of 1,000 rules and 1,000 elements. So the CSS selector matching and reflow is something we need to pay more attention to, especially the reflow as we do more Web 2.0 work. The sad thing is we see some browsers like Opera are doing something really advanced in how they determine when they have to do a reflow or not. And the ones that do the most kind of willy-nilly shotgun re-rendering are the most popular browsers, Firefox and IE. So we need to figure out what's happening in Safari and WebKit and Opera and try to get the Firefox and IE teams to adopt some of those advances in doing more intelligent rendering. So the wrap up here, here's a plot of reflow time versus total rules. And I have a tool that classifies the painfulness of rules. Like, is there a key selector, something that's going to match a lot or just a few elements in the page? And there's a high correlation between reflow time and both of these variables. So you want to look at these improvements. You're going to have to do some trade-offs for some of these suggestions. You might actually add page weight that could slow down the page. So really try to focus on the selectors that have that most ambiguous key selector in it. So don't change them all willy-nilly. Focus on the ones that are going to have the biggest performance impact. And you might also want to look at reducing the total number of rules or the total number of selectors. That's going to affect your reflow time and page load time as well. All right, going beyond gzipping. So Tony's my office mate, and he wrote this chapter 9 of my book that's coming out. So in my first book, High Performance Websites, Rule 4 is gzip components, right? And accept encoding and content encoding were added in HTTP 1.1. And so what you get is you get web clients that say, I accept gzip and deflate and possibly other compression encodings. And then if the server supports any of those encodings, those compression encodings, it can compress the response and then send back this content encoding telling the client which encoding was used, and the client can then uncompress that response. So that all works well, right? And it's really easy to turn on. Here's the line you would add to your config file in Apache 2, and this would cause all of your HTML, CSS, and JavaScript responses to be compressed. And that's kind of the main point that I made in high-performance websites was, compression really reduces the transfer size of these text responses. It's typically about 70%. So if you had a 100K JavaScript file, it will drop down to 30K, right? So that's a big savings. But typically, 3 or 4 years ago, you would only see HTML responses being compressed. But really, any text response should be compressed. JSON, XML, CSS, JavaScript, all of those should have compression turned on. But you don't want to do it with binary files. It could actually increase the size of the files. And this is a chart I'll show again at the end. This is a friend of mine, Bill Scott, formerly from Yahoo, now over at Netflix, where on one day he finally convinced the folks there to turn on compression for HTML, CSS, and JavaScript. And when they turned it on, the outbound traffic dropped in half, leaving their data center. And the ops guys thought that the site was down and everyone was just getting an error page. And they paged him and he said, the site's down, the site's down. He said, nope, we just turned on compression. And so you can imagine the speed up that this results in and also the cost savings that you'd have from a change like this. So anyway, everyone's sold, let's turn on compression. So what's the big issue? The problem is that about 15% of the people in the world, even if you turn on compression in your web server, aren't going to get compressed responses. Why is that? I just want to point out here, I intentionally misspelled the word surprise because I think it's more fun with a Z. Like something that has a prize in it, surprise should be a habit. So this and performant. Performant is not a word, but I use it all the time. So I have my spell checker accept that as a proper spelling. So how is this possible? How can 15% of the people coming into your website not get gzip compressed responses? Well, maybe they're coming in on old browsers that don't support gzip compression, right? So here's the top 4 browsers that don't support gzip compression, and maybe they add up to 0.1 or 0.2% of total internet traffic. So we're still off by 14%, 14.8, 14.9%. what are all these users that aren't getting compressed responses? So I'll give you a clue. If you broke this out by region, most of the people who aren't getting these compressed responses are coming from the Middle East. Any guesses? Proxies and antivirus software. The other one is the Vatican. It's like 100% of the traffic in the Vatican coming from the Vatican doesn't get compression. So what we see for these requests coming in from browsers that we know support compression, IE8, Firefox 3, Firefox 2, IE6, IE7, there's no accept encoding header. Or there's not an accept encoding header, but there's something that looks very close to it, but it's been munged in some way. So you can see here, X was added here, and you'll see this where the total byte size, these proxies or other intermediaries want to maintain the same byte size, so they won't remove it totally, they'll just munge it, so servers won't return a compressed response. And the reason they do that is these intermediaries are trying to filter the responses for some purpose, to look for phishing attempts or security or undesirable content. And it's just easier for them, right, to look at an uncompressed response than to write that, include that library that is going to handle gzip responses and uncompress it and then analyze it. And the thing is that uncompressing is, 5 to 10 times faster than compression. So it's not like it's going to be a big performance hit if you have to uncompress the responses. And if you looked at the time it would take to uncompress the response versus the time to download something that's going to be 3 times bigger, it's a huge win to have compression turned on. So I see this all the time. I don't believe that the developers who built these proxies or antivirus software programs intentionally want to slow down the user experience. In my experience, they just aren't aware of the performance degradation that they're inflicting on this group of users. And so we need to raise awareness of this and try to get them to enhance their products to not strip out accept encoding. So, I encourage you to go back and send me an email, check your site. How much of this do you see on your website? Do you see about 15%? Is it more? Do you have some way to detect what the cause is? Because we could start reaching out to specific vendors, especially the most popular ones, and ask them to address this to add compression support in their software product. So I looked at my site, Steve Souders, and I turned on, for 500 unique users, this beacon that recorded not just their headers, but also some behavior in their page. And what I found was it was around 15%, I got 14%, were missing the accept encoding headers. And of those ones that were missing it, they had some munged version of the header. 1% of them had a munged version of the header. And I tried to see if I could tie this to proxies or some other tool. So here are some headers that I use to do that. But I want to really quick, let's see, okay. Yeah, here we go. Boom, 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 boom. I wanted to show you this thing that I think is kind of fun. And it's locked down, so you won't be able to get into it. So I call that Dino Query. So I think the most important thing about any software project is a cool picture and a cool name. And so don't tell Bam Bam and Fred about this, but every time you reload the page, you get different pictures of Dino. But it's supposed to be Dino Query, like dynamic queries. And so it's very crude. I hope to open source, improve this a little bit and open source it. But I wanted to show it off a little bit. So basically what I do, those 500 users, I just dump their headers and some other attributes of their experience into a MySQL database. And then this Dino Query is a PHP script that's maybe 300 lines of code. And you can drop it on top of any MySQL database, any MySQL table. And it basically just enumerates the fields in the table and lets you, poke at them a little bit. So let's poke at the accept encoding header. And we see that out of these 500 requests, about 14% of them are missing the accept encoding header. And if we look at another version, another dimension on this data, like the user agent, we can see that these are perfectly normal user agents that we would expect to support compression. So why don't they have the accept encoding header? So one thing we can do, it's kind of hard to look for munged accept encoding headers because you don't know what they're going to look like. So basically, any header that I didn't recognize that looked weird, I put into this other category. And so here we can see examples of where they've munged the accept encoding header, right? So how can I try to correlate this to proxies or antivirus software? So there are some headers that are most prevalent with proxies, like VIA. And so whereas, and this is another thing I wish all plotting tools would do, is I always want to compare plots side by side. I hate having to open up two different pages. So I can look at my overall population. What's the distribution of the VIA header? In my overall population, I have about, what would that be, 50. So I have about 10% of my users coming in with a VIA header. Here, of these ones that have a null accept encoding header, it's about 40%. So clearly, a much higher percentage of these users are coming in through proxies. Another one we could look at is proxy connection. So here, 12 of them have keep alive. In the overall population, it's also 12. So all 12 of these users that are coming in through with a proxy connection header have a missing accept encoding header. So this is really clearly tied. Now, I don't have a good way with headers to detect antivirus programs, or if you know a way, let me know. But clearly, this is very correlated to users coming in through proxies. So, Okay, so what can we do about it, right? There are some things that we can do. I'm going to talk, Tony in his chapter talks about 3 different approaches to take. But I'm going to talk about one of those is basically as developers to not assume that compression is going to happen. Because this is pretty tricky. If you look at this 15% of your audience that isn't getting compression, and you average that across your entire user population, the slowdown isn't going to be that significant. But the problem is that this penalty isn't distributed across all your users. Those 15% of your users, 100% of the time, are not getting compressed responses. So they're getting a very, very much slower page load. So what can we do about that? So we can't assume that we're always going to have compression on. So there are things that we can do that we've talked about before, but even in my first book, I didn't emphasize that much because I kind of thought, well, compression will take care of this. So we can go that extra mile and do more work for this 15% of our users, like minifying. Like, a lot of times I don't minify my JavaScript because I know I have compression turned on. But for those users, minification, if you turn on compression, you get 70% reduction. If you minify it before compression, you'll get maybe another 2 to 5%. So it's not that much. Well, for these users that don't get any compression, the minification will reduce it by about 30%, 30 to 40%. So that can be significant. And let's do it to not just JavaScript, but CSS and HTML as well. Instead of inline styles, which will add more characters, try to use rules. If you have long JavaScript names, we see this a lot in the JavaScript frameworks like jQuery. Instead of document.getElementById everywhere, alias that to something that's shorter. And if you use that function again and again and again, you're going to reduce characters. If we had compression, that would just be an entry in the dictionary. It wouldn't matter how long it is. But for people who don't have compression, it's going to add up. And we could shorten our URLs by using relative URLs. So there are a couple other techniques that Tony talks about. And he's giving a talk at Velocity on this topic with more of the information if you want to come and check it out. Okay, I'm going to start. So that ends the second of 3 parts, the nitty-gritty best practices. So I'm going to start wrapping it up now. If you want to make your web pages more scalable, reduce your hardware costs, focus on the back end. Figure out how to handle more requests with the servers that you have. But if what you want to focus on is the user experience, how fast your pages are, and how they're perceived by users, you got to focus on the front end. That's the long pole in the tent. You can run YSlow, and it'll give you specific advice on what to fix. It's usually the place to start. There's more you can do beyond YSlow, but those are the basics that are going to have typically the biggest impact and are the easiest to roll out. Speed really does matter. It improves your company, your user experience. I've got a couple slides that touches on that. One is faster web pages affect revenue. We have 3 data points that are kicked around among my talks and other people doing performance talks. There's this one from Marissa Mayer, where at Google, the Google search page became 500 milliseconds slower and lost 20% of its traffic, which is directly related to revenue. At Yahoo, they just published this one a couple months ago, 4 months ago. They did an experiment where they introduced a 400 millisecond slowdown, and they saw a 5 to 9% drop-off in page traffic. And at Amazon, a former Amazon employee released this stat that they determined that for every 100 milliseconds of latency that was introduced in the page, they lost 1% of sales, 1% of conversions. So this really does have an impact on how your brand is perceived and how your website is used and how users are going to engage with your website. And that's going to impact revenue. It also affects your operating costs, your hardware costs, your data center costs, your network costs. So you can imagine if you don't use a far future expires header, then you're going to have many more requests for those static resources. But if you fix your expires header, if you remove e-tags, it's going to greatly reduce the number of hits. There's a very big website, I won't mention the name, that didn't have a far future expires header. They turned that on, and they saw an 80% drop-off in the number of requests hitting their servers. So they could bypass their next 2 hardware purchase cycles with the servers that they already had deployed. And then I showed this one before about bandwidth costs. Doing things like adding compression are going to reduce the usage of network that you have in your data centers. And that will translate into cost savings. So if you want a better user experience, how many people want that? More revenue? Reduce operating expenses? Okay, I'll take that. The strategy is clear, even faster websites. All right, that's it. So we have about 10 minutes. I'll take questions until about half the people leave, and then I'll stop, and I'll hang out for as long as you guys want to talk about other stuff. So and I guess let's try to use the mics. Yeah. So the question was, what about other kind of crawlers or screen scrapers? Could they be contributing to that 15%? So I think I know in my studies, I stripped out all of those bots and crawlers and spiders, and I think Tony did too. So these are like real users who are logged in users. So those people could be contributing, but they're probably, in many cases, not affecting it's not real users who are blocked waiting on those responses. So any other questions? Yeah. Yeah, use the mic if you would. That'd be great. Yeah. Can you introduce yourself and say where you're from?
Yeah. Hello. Yeah, I'm Dave Shepard. I'm with Traction Software in Providence, and we build a web-based application. It's actually a hypertext journaling system on the model of Vannevar Bush's Memex. At any rate, as to your gzip issue or your gzip observation and what Tony was talking about, we saw exactly that. We saw this whole munged header thing. We saw that we actually have an article in our knowledge base about this, explaining to customers why gzip wasn't working for them. And we also saw the phenomenon of a gzip buffer not filling up, and therefore the page load times. When we shut off, actually, it wasn't exactly the right thing to do. I guess we could have shrunk the buffer for the gzip output stream, but when we shut off gzip compression for HTML documents, suddenly all these imaginary performance problems went away. Yeah. So that was great. Anyway, to my question, do you have any information on how the GWT framework uses all this great performance advice that you're using. We're beginning to use that because we want a really nice, rich, interactive environment. I'm just wondering if you know what the GW team has done with that, and you can speak to that. Take my answer off the air. Thanks.
Yeah. I meet fairly regularly with the GWT team. I call them GWT, with the GWT team, and they're familiar with these performance best practices. Some of them are kind of outside the scope of what GWT does, and so it's still going to fall to the responsibility of you, the web developer, to adopt some of those. For example, like creating CSS sprites. I doubt that GWT will ever do that. They might recommend a tool or build a tool that you could use to do that, but it's probably going to be something that you have to do. Excuse me? Oh, really? So, and I know another one that I think is coming or already in GWT is at the talk I did last year, I talked about the first 3 or 4 chapters of my book about loading scripts asynchronously. And so most of the frameworks have functions you can call to achieve that, to get scripts to load without blocking other resources in the page. And so I think GWT has support for that as well. So I know that they're very in touch with making websites faster, and they want to do everything they can. I don't have the specific list of what they've done, and I know I think Bruce is doing a talk here about GWT and performance. I think it's on my schedule this afternoon to go to. So you could go and ask him. I'm sure he's going to talk about the specifics. But they're very motivated to try to do that. And that's one of the benefits of having a framework, is the more we can get these performance best practices evangelized in jQuery, Dojo, GWT, WordPress, Blogger, all these frameworks that developers and non-developers are using. If we can just make web pages fast by default, you don't have to do anything to make it happen, that's going to have the biggest increase in these performance adoption of these best practices.
Jeff Williams, University of Minnesota. What do you think of that tool that they showed this morning, the performance tool? I saw you and your buddies at the keynote. Anything you can tell if the rest of us about it? Or
yeah, I think it's amazing. And I just mentioned to the fellow in the front row who's from Minneapolis that I'm heading there over the 4th of July. So, maybe we'll see you there. Yeah, I think, well, one, it's a beautiful tool. I mean, I love Firebug, but it's kind of showing its age a little bit. And, Web Inspector, I think, in Safari is a beautiful tool. And the tool that we saw today as part of Chrome is just amazing. I mean, even ignoring the fact that they built it on, kind of standard web tools, CSS and JavaScript, is amazing. But just the work they've done with the user interface. And I think that the thing I appreciate most about what they showed is, the YSlow best practices were great to focus on 2 or 3 years ago, like turn on compression, add a far future expires header. But people who are into web development, that's kind of old hat. My guess is people here who are really focused on a faster user experience have those things done already. And so what is it that the advanced developers are working on? Well, we're all working on JavaScript, and we have a heck of a lot of CSS in our pages. And yet these tools that we have don't give us much visibility into how the performance of JavaScript and CSS and even HTML parsing, how that is affecting our pages. In IE8, there's some visibility into that, but there's no GUI around it. So that's really painful. So I think what they've done there to actually show JavaScript execution timelines, so not just how much time was spent doing JavaScript, but where did it happen in the page? I mean, in Firebug, you can turn on the profiler, and when you stop it, you can be told how much time it took to execute JavaScript. But was that at the beginning? Did it block the rendering of stuff I care about? Was it at the end where I might prefer to have it happen? I have no idea. So, yeah, I think that's an amazing tool. We're going to see more tools like that announced at Velocity, and I think that's what web developers really need, is we need visibility into the stuff that we're really trying to optimize now.
I'm Ed from FileMaker. Do you have any further data about how that 15% breaks down by region for United States, Europe, Asia, et cetera?
Yeah, Tony's going to talk about that more at his talk and in the chapter, but I'll tell you that in the U.S., it's actually surprisingly a little higher than you would think. So the worldwide average is 15%. I think in the U.S. it's 20%. And it's very high in the Middle East. And actually, I was kind of surprised in Asia is where it's a little lower than 15%. But beyond that, I don't have like a specific, country-by-country breakdown. I'll ask Tony if maybe he can throw up a slide like that at his talk. Hi.
I'm Kyle from UC Santa Barbara. What are your thoughts on CSS frameworks like Blueprint? How much of a performance hit or gain are they?
Someone asked me about the YUI reset stuff at the last conference I was at. And I'll be honest with you, I don't use reset or use these other CSS frameworks. So, if you email me, I've got cards. Email me something specific to look at, like if you have a website, and I'll shoot you back an email. I'll run YSlow and fire up my packet sniffer and spend an hour looking at it. And maybe that's something we should be focusing on more. But I don't have an answer for you on that. Any more? Okay, last one. Oh, two more. Go ahead.
Brandon Zachary, Demand Media.
Where are you from?
Demand Media, eHow, Livestrong, Trails.com, and a bunch of others. Have you ever saw like a threshold between moving something from inline CSS to a separate file, or would you just recommend putting everything in a single file, or maybe just page-specific files?
Yeah, that's a question I get a lot, and I think the best site that has struggled with that, and I don't think has found the right answer, is Facebook. I know a year or two ago, they basically took all the scripts that were loaded on any page in their site and loaded them on every page. So if you went to the front page, you downloaded a megabyte of JavaScript across 35 separate script files. And, so the advice I give in high-performance websites is, there's no single answer. I suggest that if you have, so it depends on how many pages you have and what CSS and JavaScript is included in which pages. But it also depends a lot on user metrics. Like if you're a page like My Yahoo, where people only come in and they do one page view, right? There's only one page view per session. My Yahoo doesn't have, unless you're editing or something like that, or unless you have multiple pages, which most people don't. You go to your My Yahoo or iGoogle page, you view your modules that are on there, and then you go somewhere else, right? So really, you only have one chance of serving that page to that user. So I would inline the CSS and JavaScript. Because for that, the reason to make it external is for caching. Well, maybe that user is going to come back today, but if they come back tomorrow, or certainly if they don't come back for 3 or 4 days, they're probably not going to have those external resources cached anymore. So what I recommend is, look at the user metrics. If it's like a very small number of page views per session or sessions per month, lean towards inlining. But if you have a site like Calendar or Facebook or something like that where people are doing multiple page views per session and multiple sessions, a lot of sessions per month, then you might want to make them external to benefit caching. And then as far as like when to concatenate or not, you don't want to do what Facebook did and basically include every file on every page. And you also don't want to combine them all into one file. So you're going to have to look at the pattern of what's used and try to figure out some middle ground. Last question.
Hi, Sasha Ovstyankin, I'm shopping. So the question, I'm coming from kind of a regular programming engineering background, C++, Java, whatever. And I'm just looking at you guys, working with all this CSSs, and it's kind of hard. Handcrafting all these little details of that. It kind of reminds the work in assembly language when you were, just working with calculating the pipelines of the processor and
so we're
getting
out
this
of
right.
Time.
Right.
Do you want to ask the question really quick?
Okay. So the question is this: Are you aware of any efforts to do this more on a higher level, on more automatically, so that you would just
So let me answer really quick because we're out of time, and then I'll stay after and we can talk more. Okay. There's 2 companies that I talk about quite a bit that are doing that. One is Strange Loop Networks. They actually have a hardware appliance that I think right now only works with IIS, but you put it between your web server and your VIP, and it actually changes the HTML document as it comes out. It creates sprites on the fly, concatenates scripts into single scripts, changes your CSS to use background position, et cetera, for sprites. And then there's a software solution from a company called Aptimize. Their product is called Runtime Page Optimizer, and it exists for IIS and Apache. And it's a module that you add, and it will do the same thing. Before the HTML leaves the server, it's modified, and they actually change the markup to adopt many of these performance best practices. And then they do also simple things like just change your config to turn on gzipping. Okay, thanks again. I'll stay for any other questions.